How you doing, buddy?
I'm doing good, man.
Yeah.
I feel okay. We
Nice.
just went to the gym. It was great.
Yeah.
First time in a while.
Nice.
But yeah, doing good. How about you?
Doing great.
Yeah. What is it? Tuesday? Almost the end of January. That kind of went by fast.
Yeah.
It's been a pretty good month, though. Been making some videos.
Yeah. It's been a great month.
Yeah. We have some topics to talk about, but just wanted to mention, like, we started putting a Tailwind course up on Build UI. So we've got some more videos on that coming this week. And it's my Tailwind course from Egghead. They're great about letting their kind of teachers use their content anywhere. So we're getting to make it available to our Build UI members. So it's pretty awesome.
Yeah.
I was looking at it. It's pretty good. I like it.
Yeah.
It's a really cool course. It's like things change so fast, but I think I made the first video about a year ago, maybe a little bit more, and it's all still really good. And even though there's new things in Tailwind, it's all still doesn't need to be updated in terms of how I do like a flex layout.
I was just gonna say until Tailwind changes the API for like flex.
Yeah.
I'm fine.
Good to go.
Yeah.
Exactly. But yeah, like I opened up the final version of it and was just clicking around the browser, the actual thing that we build. And it's like, looks just like Discord. You
Nice.
can like click on the servers and the channels. I didn't remember everything we built, but it's pretty cool. It would actually be, what we're talking about, our next app to build for like a Build UI kind of exclusive series. And it'd be pretty fun to take that since like the UI is done and just like wire in Remix with it or something like that.
Yeah.
It's also like a great fit for that because of like the nesting. It's like an app and it's nested.
Where you have like your servers,
I know,
your
you know
channels.
exactly how we build that
Yep.
member, right?
Yep.
I mean, you can just visualize which parts of the layouts are calling the data. And there's lots of parts of the app that fetch data that aren't navigations. So, clicking like a user's profile and having it show up in the sidebar might not necessarily trigger like a route navigation or URL change, or hovering over something,
Cool. Yeah.
the infinite scroll list of the messages,
Yeah.
that's pretty interesting. But so we've been working on that. I have some other videos coming. So just wanted to kind of start with that. But today there's two topics we want to talk about today. One is TypeScript and then one is deferred loading. So let's start with the TypeScript stuff.
All right. Yeah. So I was working on a project where I had to lie in TypeScript, and I kind of realized like we use that term a lot. And yeah, I just wanted to like talk about it. Why we do it. And when it's good, when it's bad.
Right.
And some of the things that like you kind of have to wrestle with as a developer that is about to lie in TypeScript.
Right. The moral quandaries.
Yeah.
You've been working more than I have in a project that's already exists and already has patterns around types and things like that. So that's interesting too in its own way because there's different ways. TypeScript is limited, but there's different ways that people write it. It's not so limited that all TypeScript code looks the same. There's still choices that you have. There's some flexibility it gives you.
Yep. So I think sort of first let's define.
Let's talk about the lying.
Yeah, let's define lying.
And then we can talk about that.
Yeah,
So
do that.
I mean, I think correct me if I'm wrong, but if you ever lie in TypeScript, the root of it is always like runtime data in one form or another. So what does it mean to lie in TypeScript? Well, when you define a function called add, and it takes two numbers, then the type system helps you because it will tell you if you call it without a number. And so at that point, assuming your code type checks, within the function, the body of the function, you can be guaranteed that you're working with two numbers. Again, assuming the program type checks. So you won't hit any errors related to those arguments not being numbers. So that's like the truth of the program. It's giving you information about how it's going to be called. So we would say those types are like aligned with reality. They are aligned and they're in line with reality because that's just something that you have a guarantee. It literally gives you a guarantee, assuming the program type checks. Now, the problem comes in where you have arguments where you don't know ahead of time what they're going to be called with, basically. And an example of that is making an API call where you're writing a TypeScript program. When a user comes back from the database, from the API, you want to know the shape of the data. So you type it, but it's different. In the same way that when you're writing the implementation of the add function and you're in the body, you want to be sure, have that guarantee of what type of data you're working with. You want that once you're writing a page or seeing if the user has an active subscription. And so you want those types to mean the same thing. But if you don't handle that situation right, those types are going to be a lie because they are not necessarily going to represent the data that eventually gets called with that. Because at runtime, the data could be a lot of things. And you don't type check that particular version of that program, right? So really, if you think about it, it's like in the static case where you have a function called add, and you're calling that function from the same code base, you know the possible code paths just by looking at the implementation and the callers and all of the callers. And you have all possible callers right there, and you're in a static program, so you know what the type information is going to be exclusively. Whereas if you deploy a function to a running environment and then feed it potentially anything, that's why it's harder. And that's why it's easy to lie in those situations where your types haven't actually accounted for everything. I guess in the same way, you could lie with types if you don't think about all the ways it could be called, right? I guess not, though.
No, I mean, because like you said, it has to pass type check.
Yeah.
I think the thing here is like lies in TypeScript. Whenever we do them, they don't start out as lies. So an example here is like I'm fetching data from a remote API. That remote API was it's 10 years old. It's before TypeScript ever existed. There's no types I can download. There's no auto-generated types. And so I'm writing a TypeScript program, and I don't want to just say I just fetch this blog post from this remote API. It doesn't have types, but I don't want to just mark it as an any. I know it's a blog post. So I create my own type in my app, type blog post, title string, is published, Boolean content string. And that starts out as a truth, but we would refer to this as a lie because our program has taken ownership of the type, but the real ownership of that is the API server and how it responds to you.
Right.
So for example, one day the API server could say you know what, content is optional. And so we're going to reply with some posts that don't have any content.
Right.
And our type says, no, content is always a string.
Right.
And so now this lie has just flowed through our program.
So I think there's actually two things here. There's two branches from the ideal world where you have a function defined and then the invocations are right there, either in the same file or a nearby local program. The type system can know exclusively how it's being called. And then if you type check, then the types are truth. The next level from this is not actually what you just described. That's actually two levels. There's another level, which is the data coming in is not even complex enough, let's say, to get its own types or whatever. If you actually just think about someone calling your function from another place that's not in the same program, you can have a correct implementation that type checks based on the arguments being a number. But as soon as the caller is calling it from a different location, if you deploy this add function and it gets called, you might have that kind of runtime error where your function blows up because someone passed in a string, even though that was never supposed to be allowed. But if you are running that function in an environment that is basically JavaScript, right? Because whenever these functions run, types aren't there anymore. They get stripped out when the program gets run.
So someone could open up DevTools and just type add a plus some object.
Exactly. But we wouldn't call that a lie. We wouldn't call TypeScript lying to you in that case because the only contract you have as a writer of code in that situation is that given someone passes this in, I know I'm good. Right?
Yeah. I would say TypeScript has already done its job.
Yes.
It's made sure that in your code base, you did not call add with anything that
Yes.
wasn't a number. It compiled your code to JavaScript,
Yes.
and then it gave it to you and said you deploy this wherever you want.
Yes. But I think it's important to break those two things apart, because the whole point is that the type safety you get from the invocation and the implementation being in the same file is like crucial to making it work. And once you split those things up, you lose some safety. So in your example where you have a blog post that has a type of user with an ID and a name, oh, okay, I got that from my CMS. And so now in my implementation of my app code, I'm working with a type that is given to me, and so I can trust it. But can you trust it in the same way you can trust those two functions in the same file? You can't, because someone, like you said, could go and make first name optional. And so the type
and like
the type is not the type
new
is
types,
not the
yeah.
type definition is not derived in the same strong way that it is when you have inference throughout a single application.
Okay. So you're saying TypeScript works best when you have inference through the whole application.
Yes.
You write a function, you guarantee everything works.
And when the source of truth is local,
Is in the application, yeah. And then there's another layer, which is like you have types that come from a remote system, like your CMS or some API.
Or even calling something on the command line, or like you said,
But they're actual TypeScript types that were provided to you by a third party, and those are good, but they're not as good as the first case.
They're almost more nefarious, because you seem like, I have types.
You can trust them. I have types, but they can change.
They are disconnected. The source of truth is not those types anymore. Whereas when you're in a program with all static function definitions and invocations, that is the source of truth is the functions that are right there. So you can't, since you're in a closed system, you can't change those without losing type safety. Whereas you can change a runtime system, lose type safety, but not know it.
Yep.
Because, and that's where the lie comes in.
So I almost feel like lie is like a really strong word. I almost feel like in the second case you're bringing up, it's less of a lie and it's more of like a drift.
It is a drift, but that's the whole point of the lie, which is like,
you think you
want to
safe,
minimize
but you're not.
Exactly. It does not give you the same kind of safety that you would get if you were working with a source definition that was local and therefore was always ironclad.
When it
exactly.
The type, like whenever it changed, the type was updated.
It's like the Sandy Metz implementation, not implementation, interface test. Remember the Sandy Metz story about when you have to like mock a service? It's actually the same problem if you think about it.
Okay, go ahead.
And Sandy Metz Ruby community talked about when you are using Stripe as a service and you start writing tests and you want to mock it out so that you can write tests, given Stripe returns a 400, given it returns a 500, how should my application respond? There's a risk as soon as you mock anything for the purpose of testing. But it turns out for other purposes too, right? As soon as you mock anything for the purpose of testing, you run the risk that your mocks drift with the source of truth. And as soon as it drifts, your test suite could be giving you false positives, because your test suite says, oh, when Stripe is in this state, look, our app does this and it gracefully degrades or it lets the charge go through. What if Stripe has a breaking API change? Your mocks are derived, but they're like not derived. They're not derived. They are a copy and they're a snapshot of an API at a point in time. And so it's basically become a lie. So the question is, can you trust the lie? Because as soon as you mock it, it's a lie. And the answer that she gave is one way you can do this is you have like an implementation test, a contract test, where you actually like verify. There's ways to do this in different situations where you have a test that says, Stripe adheres to this API contract and my Stripe mock does as well. And so that way, if you go to like npm upgrade Stripe, your package JSON, and they change an API, like you have a programmatic way to know that like stripe.createCharge doesn't work anymore, because you have a test that imports the real Stripe, says it responds to create API, and then your mock does too. So you npm install, upgrade the package, your contract test fails. Oh, wait, the API has changed. We missed that breaking API notice in the change log. Update that, contract test. Then your mock fails a test. So I need to go update the mock.
Yeah.
And now your mock has become true enough. In that case, probably very like it's true because the code is part of your thing. So that way, the contracts you care about, the APIs you care about are being implemented by your mock. And now you can rely on it in your tests. So in the same way, like if you think about it, that's one way that you could think about how to get information about the public API, the service that you rely on, is downloading the types. And that is like a mock of the API. That's basically what it is, right?
Yeah.
It's like a mock. And so the question is the mock that you have the snapshot of the thing at some point in time, or maybe it's an incomplete snapshot. Maybe it's just a mock. It's like it's a shadow of the API service that you're relying on. And the question is, can you rely on it? So first of all, is it a good mock? Have they defined, a user can have a first name and an ID, but it could also have a non-user if our server goes down in 500s. And here's what you'll see in that case. Because good mocks for services and package libraries show you all of those possibilities. You can put them in all those, so you can get the whole permutation of every outcome, So there's a lot to think about there. It's not just that the user has a name in the database. It's that when I call fetch and get a user back, right, there's the layers of all that in between.
Everything that can go wrong.
Yeah.
Yep.
So that is a lie. And it's I think it's okay to use the strong word lie, because I think it's important for programmers to understand the difference between a type like that and one for like a component that they're extracting in their own application. Because when you extract a component from a chunk of HTML and pass in some props and define the props and you get type errors, you have 100% guarantee in the body of that component. And that's the beauty of TypeScript, that is helping you. You're going to be thinking about the alternatives that you had missed, like what happens if this is, something else. But when it comes to, and you see that happen actually with like, great example of this is like the router.query in Next. And if you do like router.query.search, it can be a string, it can be an array of strings, or it can be undefined, right? And that's something you have to think about, because that is data coming in from a user's like system. The user has control over the URL. We don't.
Yep.
And so you have to account for all those cases. So that's an example of like a mock in a sense, but it's like an airtight mock, and it's something that's not really changing. Like once the users can enter in like data objects to the URL, it might change. But that's like a good case of like creating the type at the boundary, and it's so good that you can trust it completely. And then
it also forces you to deal with it in the boundary, at the boundary, because the very first line you write is if type of is not if type of param is not a string, then
just use this
type
default
of param
value.
is empty,
ignore
then like
it
return
or
not
something.
found or something.
Mm-hmm. Yep.
Yeah. Yep. It's funny that whole process of doing the type check is something I would never, ever do if I didn't get those type hints.
Right.
And it also annoys me every time I have
to. It
to.
does me too.
Because I feel like it adds a bunch of boilerplate.
Yeah.
But just hearing you talk about this, it's like, this actually is protecting my system, my code from outside input. And that's important.
That is important.
At the end of the day, like that's really important.
It will lead you with a more resilient app that won't break if, users do something you weren't expecting that wasn't on the happy path. You know what I mean?
One of the things is, before we get to that third case again, one of the things that's hard about, like you talked about, like, testing the contract.
Right.
That's not free.
No.
Like you have to develop that. You have to like get everyone on board, set up CI for that, whatever you do to test that.
Yeah.
So it's hard for me, like in the Stripe case, or like if we're like really depending on some third party service, it's like, okay, we can figure out some contract testing. But if my app is making like random fetch calls to random services, I'm not going to do that.
For example, in Build UI, you set up with Hasura and the CMS. We're basically have a mock of the CMS in the form of a type. And if you change a query, you regenerate the type, and so that is like, that's both in the same system. And so that's really not like a lie.
No, but it is a lie, because I could go, you download the types from Hasura.
That's true.
I could go.
Oh yeah, it's the downloading part, not the auto-gen for the queries.
Not the auto-gen.
So the auto-gen for the queries is different. But yes, the downloading part is really, but because it's simple enough, it's just us. You're right. There is a cost. We haven't taken the time to set up anything that will automatically do it every time you whatever.
Right. Right. It is. It's just us. So if you or I change a type, we'll just go in, download the types, and get them in the commit. But
Change the schema. If we change the schema. Yeah.
Just imagining. Well, I guess what we could do is like on CI. CI could just delete the types, delete the schema, download it, and regenerate. But even that, that takes effort. It takes time.
It does. And at that point, you've already written code that could be written against an actual lie, right?
But it would catch it because of my code wouldn't compile.
It would catch it, but you've already written code, and you might have to rewrite it because you haven't. You know what I'm saying? You want it when you're authoring.
Push. So write a node script that just constantly downloads the schema every 10 milliseconds.
Or it tells you you're out of date or something, like, get status, your thing's out of date. So lie is actually possibly, there might be a word that means like it's a potential lie, right? Because ideally you do want to go through a step where you like validate it. And if it doesn't conform to it, since it's like, there's a big possible set of data it could be that you handle those cases. And then once you get there, let's talk about like the case with the kind of final case, I guess, where you have the blog post that's also being fetched over the network. The blog post source of truth is in a system and it's also being accessed over the API. And so the system could change, the API could change.
And it's like a legacy system. There's no it's not Hasur.
Okay. So it doesn't give you any types that you're writing yourself. That could fall out. But then you also have the API call. I guess it's really the same problem because at the end of the day, the only way the data is getting into your program is through a fetch call. So,
but I guess it's different because in the second case that you brought up with Hasura, you download the type. So you're
but you still have to know how to do that. I'm saying at the point in time when you're writing code, if there is data coming into your system, that source of truth is not in your system. That's a lie. This is a lie. But again, lie might be
strong.
It might be too strong because it's the same case for URL parameters coming into your system, but because the type is exhaustive, right?
No. But
the source of truth for the URL is not in your system. You don't have like that data is not anywhere in you can't point to anything and show me like all of the invocations that router.query will be called with because that happens at runtime by users typing in text into the URL bar.
I know,
but there is a type that is not a lie. It conforms to it's because it's been correctly typed exhaustively and that interface is not changing, then we can rely on it. And so it's not a lie anymore. Like search is either undefined or an array or a string. Now, maybe it actually, you never run your program. Maybe you could say it's a lie in the sense that you never run your program ever with search as undefined because that no one ever actually does like ? Search or something like that. Or no one ever calls it as an array, which is the frustration that you were talking about before. Like, I want page equals 1. It's never going to be an array. Why do I have to handle that, right? So you handle it, and then no one ever passes in multiple page arguments. So then you could say it's a lie because the type is like
no.
Not correctly typed.
Back up. No. I could craft a URL.
No, I know you could.
That makes it an array, and by that exhaustive type forcing you to deal with it, your program is now robust to it. So
I understand that. I'm just saying
it's annoying, but it
would be like writing an add function where you have like number or string, and then like if type of A is string, return like error, throw error or something. But no one ever does that. So you'd be like, you shouldn't write that as your type signature because no one's ever going to call it with a string. You should just you should limit it even more because you'd rather have them have like a type error. Ideally, you would be able to say no one can pass in an array of query params called search in my case of my program. Like the user would get an error when they're typing, but they can't. I know. Anyways, digression. I'm just point being, the question is that is it actually correct to call the type definition that comes from router.query a lie? And I think the answer is no. So then we have to go back and refine what we were saying about the fact that data coming into your internal system is where lies are created, because that's a case where data is coming into your internal system from a search bar, but there is no lie.
It's not data. It's types from external systems are coming into your system.
It's not even about types, though.
It's not. Yeah,
because I could write a new router and I could give you a type definition for what possible values my router.query could be.
Okay.
So that's not an external system giving me a type definition. Like
I
you
know
can still
it's
type
not a
it.
lie. It's fine. My program is going to be robust because I can write my program in
It
a way
would be
that,
a lie if someone typed that URL router.query, if they wrote a type definition for it and they didn't include like the array case or the undefined case.
Yep. Or
then
browsers just updated.
that would be a lie, and your program wouldn't give you any information about the fact that that's a lie.
Yes.
So that's why it's different than just like mistyping something like within your code base.
But I think the key here is that the types are coming into your system from an external system. So the types aren't being inferred from your function definitions. The types are coming in from an external system, whether it be someone typing all the ways a browser can send query params.
But in that case, you're writing the types.
I'm not writing the types. I'm using your router. And
so you could just write a bad type, but that's not a lie.
Yeah,
it's just a bad type.
We're being like,
okay,
that's
it's a bad type.
Browsers could update in 10 years from now and say we have a new type of query param where you can pass in JSON directly, and then all these types would be outdated.
Sure.
But the key is that the types are not inferred from our program. They're external. They're coming from somewhere else. So the external type is a Next.js router saying these are all the ways that query params can come over through a URL.
I want to think about this a little bit more.
I like this.
No, I want to think if there's like a difference between a bad type and a type that's like a lie. I mean, okay, we can just like get back up a few levels here because we kind of like got in the weeds there. The main point is that when you hear folks say this or we say this, the type is a lie, the cake is a lie. It usually is when a system just gives you a type, because that is giving you a false sense of confidence. You know what I'm saying? Whereas if you had to type it yourself, you might be more careful. They've given you this type, and you think it is like the truth, but it's not.
It's not even about typing it yourself. It's about inferring it from your function definitions. That's
I know, but you still have to write your own type definitions for your functions, and you could be wrong. Like you could forget that people can call this with like null or undefined.
Well, as soon as someone calls it with null,
I know, but what if they
they're
don't?
not going to pass the link.
But what if they don't?
No, wait, hold on. If someone calls it with null, the TypeScript program won't compile. It'll say null is not a valid type.
What if you say A is like an array of any or something like that?
Well, then okay. Now we go into like
that's what I'm saying. What's a bad type?
You shouldn't. I want to be charitable here, and I want to throw those all out of this argument.
But that's kind of what we're talking about, which is like the types aren't exclusive, and they're not like actually accounting for the reality of every way that could be called.
The fact is that if you write a type that says I can be called with an array of any, then your function has to now handle an array of any. So you have to handle an array of numbers, an array of strings, an array of cats.
So if you do something that
dogs,
doesn't, it'll give you a error or something.
You just have to. You have said my function works with an array of any, so you better be damn sure that your function works with an array of any.
Yeah.
So that I would say is like, there's like TypeScript has strict mode where you can't do stuff like that. It's to prevent you from just papering any's to get past things you don't want to think about. But the
external system gives you a type.
Exactly. External system.
It falls out of sync for one reason or another. It's either the source of truth has changed, or the API responds with something different. I guess those both end up being the API response with something different.
Just the source of truth. The source of truth has changed. Those types have changed, and you haven't re-downloaded them or whatever. So that's one case you have to deal with. And then the other case, I kind of touched on this before. I'll just real quick, is that when the third-party system doesn't provide any types, it's an old legacy system. So you end up defining those types in your code. And I think this is, I've seen this in just about every TypeScript project I've worked on.
Right.
I'm fetching a blog post, and I know the blog post has a title, an author, and content, and is published. So I'm just going to write type blog post with those 4 fields.
Right.
And now my system, I can write components that take blog posts. I can write data fetching functions that take blog posts, and they work. But this is a thing. Is like that's a lie because
you shouldn't be as
that's
confident
a lie
in
because
those.
it can drift. The third-party system can change, and that's almost like that class of lie is almost a worse lie, because if I change the types in Hasura, I just have to re-download them, re-download the schema and regenerate the types. But if someone goes off and changes the types in a third-party system, they have no idea that I defined the type in my app around some data in their system. So, it's really scary. Like you can you can drift. I think drift might be a better word.
Drift,
but it is a lie.
Yeah,
drift.
It ends up being the type check is what's the lie. The fact that your program type checks and you have taken care of all bugs that are possibly statically analyzable by TypeScript is actually the lie, because like the program is not type check. It's not type safe, because you're going to run it passing in different data than you're telling me, right? So it's like the harm is the drifting is part of it, but the harm is like TypeScript's not giving you the benefit that it could be if it knew the correct information, right?
Yeah.
And so you have like a false confidence in your overall program.
It's almost worse because it's giving you the confidence it's like confidently lying. It's confidently lying.
Yeah. It's a programmer.
Yeah. I was going to say it's me.
So when you're in this situation and you have to deal with this, which a lot of times you do, we also talk about like keeping the types closest to the boundaries as possible, because the worst thing you can do is what's worse than one lie is like 10 lies, you know? So if you have 10 different parts where you're typing different subgraphs of your blog post and they're all around your code base, you're losing type safety every single time you do that. And this is why in general you want to rely on inference as much as possible in TypeScript, because you restrict your sources of truth to the edges. This is like there's a good analogy here with functional programming, right? With like side effects and transforms, like your effects are like at the edge, and like everything else, if you put effects everywhere, you like lose the benefits of the system. It's the same thing. And so you want to rely on inference to flow through the system, because if you don't, every time you come in and define a type, then you introduce the possibility of defining another lie, which removes more type safety. So this is where like libraries like Zod come in, because they kind of operate typically at the boundaries. But even if you're not using Zod, then you just still want to keep your definitions up here somewhere. And then once you get past that, you just let them flow through your functions.
Yeah, like maybe just keep them right next to the API calls. And then if you have like different types of blog posts, you use like the TypeScript utility functions, where it's like, you're not just defining new types for like a published blog post and unpublished. Right. You're more taking that original blog post and saying like unpublished is like
narrow it down.
Yeah, exactly. Omit like the published update.
Yep.
And just so you can
derive
just change
and
that
narrow
one thing.
Yes, exactly.
Yep. I really like
where the data comes in the system. API calls, the URL, form inputs. Those are all areas where this problem presents itself the most, because those are the areas that you're interacting with data that's, again, not within the same like static program, basically.
Yep.
This is like what what's the language? Elm. When you get I think Elixir might do this too, but when you make an API call, so for folks who have never worked with like completely type safe languages, I haven't, but I know enough about them to know that like not only do they have types the way TypeScript does, but they actually run in that same environment. So it'd be as if like TypeScript doesn't ever get rid of the types to run. Like the runtime.
Oh, they do validation.
Well, that's why Elm literally makes you a guarantee that you will never have runtime errors. You can't have a runtime error in an Elm program, because you can't even compile and execute it if you don't type check effectively.
Wait. So if I say like I'm fetching a blog post and it has a title and I make that fetch request in Elm,
you can't do that without handling the case where the fetch request comes back as undefined or something else. So everything, it's impossible. It's literally impossible to have a runtime error in Elm.
Does that lead? I mean, I've never done Elm, but my like initial reaction is like, does that just lead to like try, catch, and if statements everywhere?
I mean, you have a lot of stuff. I don't know, but okay. I mean, you know, for example,
or maybe I know there's better ways to do this in TypeScript. So maybe there's better ways to do it.
Oh, for sure. I mean, for example, like the whole, when you fetch JSON, you have to parse it into a type data structure. And if it doesn't parse for whatever reason, you are now in the error branch of the application, and you have to handle that some way. So there's no way I can give you a response you didn't expect and at runtime and break your program. Your program is not going to break from a runtime exception.
Because it knows, hey, you could get
now
a response.
You're right. What you didn't expect is actually something you are handling because I forced you to. Right. That's how Haskell works. And I think not Elixir, but Elm is 100% type safe. So they have no runtime errors, which is pretty cool. I mean, that was like their whole selling benefit at the beginning.
Now you can still get, to be clear,
You can still have bugs. You can still write bugs. You can still write programs that have behavior you don't expect. You can still
have an error on the screen and such that like you show a message like
of course.
I crashed.
That's not an exception
Right,
though. Like,
but you dealt with that. Like you, the
you're
programmer,
going to be, it's a code path in your app. Yeah, exactly.
Very cool.
Yeah, isn't that neat? So yeah, this is the same kind of idea. And this is basically what like Zod does, which is you fetch the JSON and then you have a type, which is potentially a lie, but Zod is going to help make that, less likely to be a lie, because Zod is acting as that JSON parser layer from Elm, where you take the data, you parse it into an object, parse, right? You just you put it into an object and validate that it looks like the user that you thought it was going to. And if it doesn't, what do you do? So what do you do, right? And then once you pass it and it does, that's where like the lie ends. That's the whole idea of like Zod, or keeping these lies at the boundary. Because now you can't point to me, hey, you wrote a component down here and you said you were going to, give it a user and it's going to show the first name and last name and concat. But I gave you a user without a first name. That's your fault because you didn't handle that case. You can say, no, you gave me a user and the type says that has a first name and last name. So it's not my fault because it was the fault up here. We didn't validate that it has a first name and last name. And if it doesn't, we shouldn't be passing it through the system, because then those drifts and those lies, they add defensive, horrible code everywhere. So that's why you want to keep it at the boundaries.
Cool. I want to back up a little, talk about Zod, because I've found that Zod is a really, really nice way to handle this case, especially the third one that I was talking about, where you have to define your own types based off the legacy system. So with Zod, you define, I think they call it a schema, where it's really, you can go nuts with it. So you can say like, I have an email address field and that's an email. I have a first name and it's, 1 through 5 characters. I know
so you can do validations beyond what you could express in TypeScript.
Exactly. Way, way, way beyond. Yeah.
You can write JavaScript.
Yes.
You can write arbitrary code.
Yeah, you can write, yep, exactly. So then you write your Zod schema and you write that in JavaScript. So it's a JavaScript API that looks like that. But then Zod has this infer, and you can take that Zod schema you wrote and just extract the type.
Oh, cool.
And so now you have a type that now you can give to the components in your system.
I actually haven't used Zod yet. If you can write arbitrary JavaScript, what would it infer from that?
So
I'm going to write all my schema definitions so crazy. So it's just like first name, last name, any, age, any. So here's your type, buddy.
I haven't.
You can't hold me down.
I haven't kicked it enough to know, like, if I define something that can either be like the string Ryan or the string Sam, does that like directly translate to a union type of Ryan and Sam, or does it translate to a string? Like all the Zod stuff I've done is, I mean, it's the case that I started with.
Badass,
it's taking a response from taking something that I was typing I was typing out what a legacy API was supposed to respond with. That thing would drift and would just seep through the entire system. And so using Zod to basically create a type, validate it, and then infer the type from my validation such that I could use that type in other components, other functions in the system. And I think that's a really nice way, just kind of like going back to what you said about Elm, that's a really nice way to lie, because you're lying, but you're saying like, hey, if I'm ever wrong, like call me out on it. You know what I'm saying? And I think that,
for instance, you can't lie. For one thing, you can't lie in Elm. It's not a lie. It's not a lie.
Okay. Yeah, I guess
I guess you would say this is not. I mean, this at this point, assuming Zod is.
Yeah, it's
assuming
not a lie.
Zod. It's not a lie.
So it's funny because when I was writing this, I was like, well, I'm lying, but at least I'm lying with like a runtime check.
I'm lying with style.
I'm lying with.
No, the runtime check is what gives you a type that you can be 100% confident in, assuming there's no bugs in like Zod library.
Because I know.
At that point, you've only reached that code path.
If my Zod validation fails, the rest of my program hasn't run, and therefore the rest of my program never got the lied type.
It's just like being in the body of that ad. It's being in the body of that add function and knowing that you're working with two numbers. That is what it means to be like in the type safe world and have TypeScript giving you the benefit. The boundary is a caller, and so
it's like a nice little gate.
Yeah.
So, I need
to play with that. I haven't actually played with it yet.
I should go crazy, and I should add like weird. I was just doing stuff like is a string, is a number, is a Boolean.
And those are all methods that it has, right?
Yeah.
And that's how it knows.
That's
how it knows how to infer. Like, because if you were putting arbitrary
dude, to me, it's all magic. I mean, really, like,
it's pretty cool. Yeah, pretty neat.
Yeah. Okay. So
anyways, we got in a little weeds there at the beginning, but I think there's a high level thing here, which is like, you should be aware that when you work with external systems, that it's very easy for like types that are actually lies, to slip into your system. The example of the query router is actually an example of like a non-lie, because they've been exhaustive in terms of what the URL can be, and you have to deal with them, which is sometimes annoying, but that's the benefit. It means you won't run into a bug when someone puts something in the URL you don't expect. Usually when we interact with systems like APIs, we're writing them ourselves. So we don't have the same, diligence and care and attention for every piece that an OSS maintainer, a framework maintainer would give. And so it's very easy to just call an API endpoint, and you want to add a type to it so that you can use TypeScript, and you kind of know, this is going to be a number. Steve over in the backend department told me it's a number, so I'm just going to say it's a number. That's like the lie. That's like where you should have your spidey sense should be going off. And you can use Zod. You don't have to use Zod. The idea is probably do it by yourself first, so then you understand the problem Zod is solving. You say, I have a fetch request here, then response .json, and then you now have a user, and then you say user equals await response.json as, first name, last name. That's like you're lying. At that point, you are 100% lying.
And that's exactly what I was doing.
Yeah. Like, right. Because it's the easiest thing to do.
Yeah.
Yep. So,
dude, I even think one of those, like the JSON thing, has a generic where you can just say, hey, guess what? This response I'm getting back, it's a user with a
fetch does that. You take
I think like response.json something does it. But it was like,
enter lie
this
here.
Is what but this is what I ran into.
Tell me whatever you want.
This is what I ran into. And I was just, and then I had that thing, and I was just creating a type, ripping it through the entire system. And
right. So it would be a good exercise by yourself to say, okay, how can I get through and make sure, maybe I don't care about handling every 300, 400, 500 error or whatever, or if the response is okay, or if the data does come through as a 200, but it's not what I expect. How would I just say, okay, let me make sure it looks what I think it looks like, and then I'm going to give it a type. And at that point, if I've written that code correctly, it's not a lie. It still could be like, you don't have quite as much confidence because you could have written a bug, but at least at that point you're doing some. I think that would help for people to sink in that this is like a runtime. It has to happen at runtime to understand this, for you to be able to like back out the types from the
teasing the confidence that TypeScript gives you apart from the runtime confidence.
The runtime like variability, like the indeterminate parts of it.
It's funny. I kind of feel like this is going to sound really stupid, but I kind of feel like I wish I got more reps in working with like legacy systems to actually really push this, because this was just one little thing that I was working with, but it had a really, really big effect.
On how you, maybe don't be careful, man. You might get what you wish for.
Like
you're going to call up Sam Ryan, you available for some consulting? We've got a 15-year-old Perl script. Actually, Perl script system would probably be 30 years old at this point.
I know, but it is something that at least the lies we're dealing with are just re-download our types. So that is something.
That is cool.
I feel less like we need that runtime validation.
Right.
But it would be good to it would be good to maybe have in a few like key spots,
And this is talking to like CMS.
So
but it's at build time too.
But
even still,
I'm assuming.
So you're assuming like 200s, or like you're assuming the response is coming back.
Wait, in which case?
I'm talking about. You're saying you feel like you don't need the runtime validation like Zod part.
Yes, when I feel like there's less of a need for that. When
have the latest
I'm
types.
Ingesting types that someone else is giving to me, even though I know those types can drift. I feel like I need the validation when I'm literally looking at API response and handcrafting types.
Yeah. Now, does the types that are generated to account for like API responses being down because of like a server being down, like database error 500? Like, are you forced to deal with the API giving you a 500 in part of your program through type? Does TypeScript force you to deal with that? That's the question. If that makes sense, that would be interesting to look at.
I think no, because I think the fetch request can throw, and so I have to like wrap the thing that's calling the fetch request.
Okay, so the type you're doing like as type, and the type is coming from the system, but you are writing.
No.
Is it like this? Is it like CMS giving you an SDK where you say like
exactly
like a Prisma thing? Like a Prisma would be able to return to you a type thing. You know, that's not a lie.
Prisma's types are really good.
Yeah,
Prisma's types, they are a lie because you could not run Prisma migrate, go edit your database with some other tool.
And they're not pulling from that.
No, they
pull from generated. Okay, so that in that way they're a lie, but
the feedback loop with Prisma is much faster because every time you run a Prisma command, it's going to regenerate those types and put them right on disk. Where I can,
but you could run it, and I could be running your code, but without your migrations, basically.
Yeah, something like that. I'm sure we could. Yeah. But it's much more likely I'm going to go edit the CMS while you're coding, and you don't pull down the latest version of the type. So
interesting.
Anyway, I feel like the third case when I'm handcrafting is where I need the validation. When I'm downloading types, I probably put a little too much faith in them. But yeah,
that's interesting.
That's just like very.
You're being pragmatic. You're working.
Yeah. Also, that has been my experience so far. Maybe I'm going to change in a month from now.
Right. Interesting. So the lies can all pop up all at the edges, at the seams of a program where there's external systems involved. That's where all these things have in common. So pretty interesting. That'd be a fun little YouTube video to make.
Yeah. Lying in TypeScript.
Yeah.
I thought we were going to have a nice little podcast where we just buttoned up this topic and it was like, just easy Tuesday afternoon. And now
I have a lot to think about.
Yeah. Now I'm like, I need to go make 20 apps.
Same. That's exactly what I'm feeling. Like I got to install Zod. I want to like learn Elm. So I see what happens there. That'd be pretty interesting to see. But no, that was a good topic.
Isn't it so much easier when you can just lie?
Yeah.
Just lie.
I'm just going to keep external systems out of my code. That's the easiest thing is to write a stateless program.
Yeah. There you go.
With just functions.
There you go.
He's like, I will have literally no type lies in my whole program. It also won't do anything. Cool. Well, I think we should wrap it there. Yeah. Maybe next week we'll pick up. We thought we were going to talk about a second topic, but that was a nice one. Let's do the deferred discussion.
Absolutely.
Brian Florence has been tweeting about the defer utility in Remix, which is pretty interesting, and streaming, how it works with streaming, and coincidentally, I just made like a little short video on streaming in React Remix. Next.
Third time.
Next, 13, which is really cool. But it's neat to see like things popping in, and like is it because of JavaScript? Things popping in, the browser spinner still going, but like your page is changing. Is JavaScript running at that point?
Yeah, JavaScript's running. JavaScript's like placing new data as it streams in.
We'll have to
it's really
talk about it
next
week.
Talk about it.
Cool. All right, everyone. Thanks for listening, and we'll see you next week.
Bye.
Bye.